Morning guys. So in day one we discussed basic concepts around matter. So in this session we're going to discuss a bit complex concept like latent heat of evaporation and latent heat of fusion. For this to be understood well, we need to understand boiling point and melting point also. So that's why I included. Apart from that, I have taken few questions which has been answered very well. So hope you guys will enjoy it. Thank you. The next question which we're going to take is it has give reasons. A gas completely fills the vessel in which it is kept. A gas completely fills the vessel in which it is kept. Why it happens? So let us try to understand first. So we know that in gas, suppose this is a container and in this you have filled up gases. So you know the force of attraction between the particles of gas is very low. Since the force of attraction is very low, so what will happen due to that? Yeah, tell us. The energy level of the particle will be very high. Since the energy level is very high, so the particles of gases move freely and they have tendency to escape from each other. They have that kind of tendency. Yeah. So that's why they used to fill up the space. This is what I've written. Since you can describe it in your words. This is low and this is high. Since the force of attraction is low, so energy level of the particles are very high. So due to that, the particles move freely and quickly fills up the space. Yeah, guys, fine, fantastic. So let's go through part B. A gas exerts pressure on the walls of the container. Why it happens? So in the same way I have written, see this particular example. This is a container in which gases are filled. So these are the particles. Red dots are the particles of gases. So we know that force of attraction between the particles of gas is very low, energy level is very high. So the particles of gases have a tendency to move away from each other. The particles keep on striking the wall of the container and exerts pressure. So as shown here, because they want to move away from each other, but they are enclosed in a container. So what they used to do, they consistently uh, put on pressure on the walls of the container. This is how it happens. A wooden table is a solid. Why it is? Because the shape is fixed. It is as simple as that. The shape is fixed, so you can call this a solid. We can easily move our hand in air, but to do so through a solid block of wood, we need a karate expert. That's fine. So this is gas, simple. The particles are located far away from each other. The shape is not fixed. Yeah, shape is not fixed, so you can easily pass through your hand. But what happens in case of solid? In solid, particles are located very close to each other. Very less space is available. Overall, this makes the shape of the solid fixed. Since the shape of the solid is very fixed, and if you want to deform it, yeah, so it will be very hard for you. So you need a karate expert. So that is the reason. The next question is, liquids generally have lower density as compared to solids, but why? You must have observed that ice floats on water. That's good. See, in case of liquid, force of attraction is lower, so the particles keeps on moving, and you can see here sufficient space is available between the particles keeps on moving and fills up the space which is available. So this part we have already discussed while discussing the concept of diffusion. But in case of solid, the force of attraction is very high, so very less space is available. Also the energy level is very low. So if you see diffusion, as such diffusion doesn't take place in case of solid because the shape is fixed. Yeah. So what is density? Density is mass per unit volume. Yeah. Suppose the volume is same here, liquid and solid, this two particular volume is same. So what do you see here? Whose mass is lower? Here lesser number of particles are located in this volume, and here more number of particles are available in the same volume. So the density of, in general, the density of liquid is lower than that of density of solid. So the phenomenon of floating, yeah, suppose the phenomenon of floating is based on the concept of density. For example, you take an example of argon. You have taken solid argon. This is liquid argon. Okay, you just keep it on the top level. So what will happen? This will sink. This will start sinking to the bottom. Why? Because this is solid form of argon, so it has higher density, so it will sink. So this is true for most of the liquid. It happens, it is true. But water is a very special substance. Yep. So apart from this property that particle used to fill up the space and all these things, water has a very special substance. So let us discuss that thing. Suppose you have a drop of water, okay, and in this you have millions, billions, trillions of molecules. So let us first try to know what is the formula of water molecule. This is H2O, okay, and let us analyze this particular one drop of water at microscopic level. This is just virtual actually. This is drawn to make you guys understand. One oxygen atom needs two hydrogen atoms in order to make one water molecule. Okay, and if you see the bonds which I have drawn in between them is broken. I have shown with broken lines. So what does this mean? This means that this bond which I am talking about is transient in nature. This is not permanent bond. They keep on forming and breaking, and this type of a special bond is called covalent bond. Yeah. So in water molecules, multiple covalent bonds exist. So in a drop of water, you can see millions, billions, trillions of covalent bonds are there. Since the bonds are not permanent in nature, so they keep on forming and breaking. So now analyze with the help of temperature. So here I have drawn temperature energy graph. On this axis temperature is shown, and on the x-axis I have shown energy level of the particles. We all know that if we low down the temperature of a sample, okay, so what will happen? The energy level of the particles will go down. Yeah, but when it reaches 4 degree or below 4 degree, okay, breakage of hydrogen bond will not take place, because hydrogen bond itself has a certain amount of energy, and if you want to break that, okay, you require the equal amount of energy. But below 4 degrees Celsius threshold is broken. Okay, so no more breakage of covalent, this hydrogen bond will take place, and this will get frozen. This will start freezing. Okay, so what will happen? It makes the volume V factor, this volume factor, more. So volume increases. This is a bit different. Volume increases because this is all because of covalent bond, which is transient in nature. It keeps on forming and breaking. At 4 degrees Celsius or below 4 degrees Celsius, breakage of covalent bond is not possible. So the sample of water start acquiring a fixed shape below 4 degrees Celsius, and the volume remains same. So as we discussed here, same thing we will apply here. Density equal to mass by volume. Yeah, mass is fixed mass. Okay, so since breakage of hydrogen bond didn't take place, so no more shrinkage in volume took place. Volume remain same. So due to that, it makes density lower. It is different from other materials. See, density of solid is higher in most of the cases, but in case of water, density of ice will be density of ice will be lesser than density of water. Since the density of ice is lesser, so they can float over water. Make sense? They can float. That's easy. So next concept which we're going to talk about is latent heat. Okay, so before we discuss things about latent heat, so there are two things which we should be aware of, that is melting point and boiling point. So let us see what they are. So melting point, I have written it for you. So the minimum temperature at which solid starts melting, okay, at the atmospheric pressure. This is a keyword, so always pay attention, guys. At the atmospheric pressure is called its melting point. It indicates the force of attraction between the particles of matter. So that means, what is melting point? So this is a substance, okay, and you are heating it up. So at a certain temperature, the substance will start melting. Yeah. So but and that particular temperature is called melting point. Here the important thing is at what pressure we are talking about, at 1 atmosphere. So let me tell you what is atmospheric pressure. Okay, in a normal condition, okay, when you are in your classroom or at your house, so if I ask you, like, how much pressure is exerted by the atmosphere upon you, how much pressure is exerted by the atmosphere upon your body, so what is the answer? Answer is 1 atmospheric pressure. Okay, so if you want, you can convert it into the pascals, so that is another thing. But if you go and reach the top of Mount Everest, which is approximately 8.5 kilometer above the sea level, okay, so what do you think, how much pressure will be exerted by atmosphere here? Lesser pressure will be exerted by atmosphere here when you are at the top of Mount Everest, because the concept is very simple. Atmospheric pressure, so let us denote it with the word ATM. Okay, atmospheric pressure, sorry, ATP. Atmospheric pressure is indirectly proportional to height. When height increases, atmospheric pressure will be decrease, uh, will decrease, so, and vice versa. So this is all about melting point. So we had to take care of at atmospheric pressure. Okay, this is a key word. Melting point, as the name suggests, the minimum temperature at which something melts. The only thing which we have to keep in our mind is atmospheric pressure. So similar is the concept with the boiling point. Okay, so boiling point is same, the minimum temperature at which something starts boiling, but again the keyword is atmospheric pressure. Okay, at 1 atmosphere. So again, if you go and when you are at sea level, yeah, when you are at your house and you boil water, so at which temperature it starts boiling? The boiling point of water is 100 degrees Celsius. Okay, but when you go and boil water at the top of Mount Everest, it will not reach 100 degrees Celsius. It will start boiling below 100 degrees Celsius because atmospheric pressure has been reduced over there. So that's all about it. Yeah. So now, so one more thing, last thing. The melting point of ice is 0 degrees Celsius. Okay. So guys, we are pretty much familiar with degrees Celsius. This is a unit of temperature. But if I ask you what is the SI unit of temperature, okay, so what can you say about it? That is Kelvin. We denote it with the letter K, and there is a relationship between Kelvin and degree Celsius. 273 Kelvin is equal to 0 degrees Celsius. In fact, 273.15, I have just approximated it. Okay, it should be 273.15 Kelvin is equal to 0 degrees Celsius. Yeah. So if I ask you what is the melting point of ice, Okay, so you can say 0 degree Celsius or 273 Kelvin. Yeah, and if I ask you what is the boiling point of water, 100 degree Celsius or 373 degree Kelvin. Okay, so now let us go on and jump on to understand what is latent heat. So before we understand latent heat, just forget this, and we are going to perform an experiment. Okay, so what we are going to do here is we have just taken some cubes of ice from our from freezer. Okay, yeah, and put it in a glass. See this picture, just concentrate here. Yeah, and you also put in one thermometer in it. This green rod is thermometer. Okay, so and you keep a burner below it. Yeah, so what is the temperature which this thermometer will record of this sample? It will be 0 degree Celsius. Okay, you leave it for some time. What will happen? Fusion will start happening. Fusion means melting. Fusion and melting is same thing. Fusion will start happening, and we have already discussed the melting point of ice is 0 degree Celsius. 0 degree Celsius means 273 Kelvin. So fusion will start happening at 273 Kelvin. So what you will notice after few minutes that most of the ice cubes melted. Yeah, I mean converted to liquid water, but still there are some ice cubes which are in smaller in size still floats over the surface of water. Yeah, and if you and you are continuously heating up the sample, so what is the temperature? You still notice that it is 0 degrees Celsius. So why it happens? This is something which is very important for us to understand. It happens because whatever heat energy we are supplying from this burner, yeah, this is absorbed by ice. Okay, and the particles of ice move away from each other due to that energy. So when the so in the solid state, the particles of ice were very intact. Yeah, they had very less energy. We supplied heat energy. Okay, they absorb, the ice absorbs, ice particles absorb, and the particles gain energy. Hmm. And this is how they started moving away from each other, and they got converted into liquid water. Okay, so temperature will still be 0 degrees Celsius. And now you go and just wait for 1 or 2 minutes till all the ice melts, only liquid water. Okay, what is the temperature? You gonna guess here. How much is the temperature here? Temperature will still be 0 degrees Celsius. Again the same reason. Why it happened? Because whatever heat energy we supplied, it got absorbed by the ice particles. Yeah, and using that heat energy, the ice particles gain more kinetic energy and uh, started converting into water, liquid water. That's fine. Now still you are supplying heat to the container. Okay, so what will happen? Evaporation will start taking place. Evaporation is, for now you can say, is like certain vapor will come, some amount of vapor will start coming, but the water will not be boiling. Okay, water will not be boiling, but vapor will start coming. So at this stage, in between this stage, here the temperature was 0 degrees Celsius and you are still supplying the heat. After some minute, if you go and notice the temperature, you will find that the temperature got increased a little bit higher. So you can say it is 50 degrees Celsius, 60 degrees Celsius, depending upon the time, how much, after how much time you're going to get, you're going to go and check that. Okay, so till now evaporation only will take place. Don't worry about that. I will explain this term, evaporation and evaporations. Okay, for now you can say evaporation is, in evaporation some vapor comes out of liquid. Okay, but the sample is not boiling. Okay, you are continuously supplying heat, so temperature will increase. So temperature will increase till a certain point, till 100 degrees Celsius, after which still you are supplying heat. So what do you notice? You will notice that there is no more increase in temperature of the sample, no more. So In the open conditions, that means under 1 atmospheric pressure, the maximum temperature which water can attain is 100 degrees Celsius, and this is the boiling point of water. So at this, when the sample will acquire, this water sample will acquire 100 degrees Celsius temperature, the amount of water will start vaporize. Okay, so more and more vapors will come out of the container, and at this stage things will start boiling actually. So let me represent it. So this will be boiling, so you know, bubbles, it will be bubbling. Okay, but at this stage no bubbling. Okay, yeah, fine. So what we have seen that we have seen that in this stage, till fusion took place completely, the temperature of the sample was constant. Did you notice why it happened? Because whatever heat energy we supplied, it was absorbed by the ice particles, and that is how ice particles got extra kinetic energy, and due to which it start moving away from edge, and in turn the ice got converted into water. So from this step to this step, the temperature remained same, that is 0 degrees Celsius. So this particular phenomenon is called fusion. So fusion is simple melting. And how much heat we have supplied, if I ask you? So the answer is latent heat of fusion of water. This is case of water. So if I ask you, like, till this point, till all the ice melts, just melts, just be careful, till all the ice just melts, don't include that, just melts. Okay, if I ask you how much heat you have supplied, so the answer is latent heat of fusion of water, of ice, sorry, of ice. It will have certain value. And now from here, 0 degrees Celsius to 100 degrees Celsius, how much heat you have supplied to the container? The answer is latent heat of evaporation of water. Yeah guys, so hope it makes sense to you. So I have defined this latent heat of evaporations and what is latent heat of fusion. Latent heat of fusion is the amount of heat energy that is required to convert 1 kilogram of solid into liquid. Yeah, it's very simple. At atmospheric pressure, we should pay attention. At its melting point, again important, is called latent heat of fusion. Simple. And similarly, we can define what is latent heat of evaporations. The amount of heat energy that is required to convert liquid into gas at atmospheric pressure at its boiling point is called latent heat of evaporations. Yeah, it's a very simple term. Okay, so let me explain to you what is evaporation and what is evaporation and what is the difference between that. So actually, evaporation is a surface phenomena, okay, and boiling is a bulk phenomena. See, actually, I wrote it down here. The concepts are written down here. So this is evaporation. This parts deal with boiling. Okay, this is boiling. Sorry, this is evaporation. This column is evaporation, and this particular column is vaporization. So in case of vaporization, what happens? Water boils, okay, but in case of evaporation, water doesn't boil. It the phenomenon of change of liquid into vapor at any temperature below its boiling points. Below its boiling point. So this is the key word. So this is what I told you, that it has not yet acquired 100 degrees Celsius. It is well below 100 degrees Celsius, okay, but it is more than 0 degrees Celsius and probably more than room temperature. So, and it's a surface phenomena. Evaporation is a surface phenomena. So some vapor will start coming out of it because we are supplying heat. What is evaporation? Evaporation is a surface phenomena and vaporization is a bulk phenomena.